So this is solving systems of conics. Thank you to Mr. or Mrs. whoever who had this worksheet out there. I stole it from you, but you said it was reproducible, so I did. So we got y equals x squared and y equals 3x minus 2. We're going to do 5 of these problems in class. You're going to choose 4 to work on your own. First, we got to identify what the graphs look like. What does the first graph look like? Does anybody know? It's either going to be a line, a circle, a parabola, an ellipse, or a hyperbola. This one's a parabola. How do you know that it's a parabola? One thing's squared, one thing isn't. Yep. What's the second one? It's a line. So let's first sketch the graph. I'm sorry, not all the lines show up when I print this on the smartboard. For some reason, it can't detect all the lines on there. I don't know why. So, y equals x squared, vertex is at 0, 0, and it goes up. So I just draw a parabola to the best of my ability. This isn't an exact sketch either, you guys. It's not, this is a general sketch. 3x minus 2, what does that look like? Down 2, slope of, if I go up 3 and over 1, up 3 and over 1. According to my graph, how many times does it appear that they intersect? Twice. If I didn't draw the graph right, maybe they only intersect once. Or, it's possible, I guess, that they don't intersect at all. But at least your graph can give you an indication of, if they do intersect, it sure looks like it's going to be the first quadrant, doesn't it? So, we have 2 possibilities to use to solve for systems. We have substitution and we have elimination. Do you know if you're going to use substitution or elimination here? Substitution, because you know what y is equal to. So we are going to take what y is equal to, namely x squared. We're going to plug it in for y. We get x squared equals 3x minus 2. How do you solve the second degree equation? Set it equal to 0. Does that factor? What if it didn't factor? If it didn't factor, you'd use the quadratic formula. Those are my x values, my intersection. 2 and 1. How do we find the y values? Plug them in. You can plug them in either one. 2 squared is 4. 1 squared is 1. Do those points seem to fit with my drawing? Are they reasonable? I would agree. They're reasonable. So I'm confident with what I drew there, and I'm confident with my answers. Any questions on the first one? Pretty straightforward, huh? Let's look at one that's not. Go ahead. I plugged the 2 back in. 2 squared was 4. Let's look at one that's not as straightforward, okay? Let's look at number 2. What's the first graph look like? Yep, it's a line. Second graph? Parabola. But they're not in the same form. Okay, the first one is in standard form. The second one is not in any form that we recognize. So let's work with the line first. You can either put it in slope-intercept form, or you can graph it by finding the x and y intercept. If I cross out the x to find the y-intercept, I have negative y is 4. So what is y? Negative 4. So 1, 2, 3, 4. Now if I cross off the y by making it 0, what is the x-intercept? Positive 4. There's my graph. If you're going to graph a parabola, What's the most important part to find on the parabola? Vertex. Let's find it. You've got an equation here of y equals negative 3x squared plus x plus 8. If I solve for y, that's what I get. That's not in vertex form. If it's not in vertex form, what is the equation you use to find a vertex? Negative b divided by 2a. So that's our formula to find a vertex. Negative b is negative 1. Divided by 2a would give me negative 6. So we got 1/6 is, 1/6 is the x value. To find the y value, I can plug it in. Negative 3 parentheses 1/6 quantity squared plus 1/6 plus 8. And I get 8.08. What happened? Did the whole thing move? Why can't I move this? Come on. I already tried that. Whatever. Okay, it all moved, I'm sorry. We'll try to do our best here. Okay. So, I've got my vertex. We know that our line goes through positive 4 and negative 4. So we got that line, and then we know that the parabola has a vertex of, we said 1/6 and 8.08. So if we graph that point, and does it go up or down? Goes down, and it's actually a fairly sharp parabola because it's got that negative 3 in the middle, around the front. Okay, so that's our shape. Do you know whether you're going to use substitution or elimination for this one? We're going to choose to use substitution. And what we can do is this. You have this y value right there. And if I go negative y equals 4 minus x, and then divide by negative 1, and I get y equals positive x minus 4, I could take that y value and plug it in right there. So it appears from my graph that I have 2 intersection points. Now we need to actually write the new equation. If I plug that in for y, what does my new equation read? Minus x plus x minus 4 is 8. So now I'm going about my algebra. What do you notice cancels? The x's go away. I'm left with 3x squared minus 4 is 8. Add the 4. Divide by 3. Square up both sides. I get x is equal to plus or minus 2. So the x value is positive 2 and negative 2. How do I find the y value? Plug it back in. I have this nice equation right here. It says y is equal to x minus 4. So I go 2 minus 4 is negative 2. I go negative 2 minus 4 is negative 6. What's that? If I chose elimination, you actually can do the same problem with elimination. If you would multiply the top through by a negative 1, I'm sorry, if you would just add them together like you see the x and the negative y, those would go away. So I chose the substitution because I thought that would probably be what most people would be familiar with. So you could use elimination. Does that seem to match the points? Do they seem to match my picture? Yeah, over 2, down 2, back 2, down 6. Yeah, we're in good shape. We'll do one more together on the front side. On number 3, you know what the first graph looks like? This one's kind of tricky. You haven't seen it for a while. Circle. Very good. If you would divide through by 25, you would see it would be stretched 5 vertically and 5 horizontally, which makes it a circle. Because a lot of people, when they look at that, they see ellipse. But, you know, like I said, when you divide by 25, you got 5 in each direction, so it's a circle. So what's the radius on this guy? 5. So I'm going to go up 5, over 5, down 5, 1, 2, 3, 4, 5. Taylor Willis thought I was very talented at drawing circles. I will say that my 4th hour circle was better than this one. What's the second equation? It's a line. I'll cover up the y value. What's the x-intercept? 1. Cover up the x. What's the y-intercept? Negative 1. I'm pretty confident by that drawing that I'm going to have 2 intersection points. And I'm pretty confident I'm going to have 1 in the first quadrant and 1 in the third quadrant. Elimination or substitution? Substitution. I'll solve for x. X equals 1 plus y. Take 1 plus y, plug it in for my x. 1 plus y squared plus y squared is 25. What is 1 plus y squared? Nope, y squared plus 2y plus 1 plus y squared is 25. Combine like terms. Instead of subtracting the 1 over, let's subtract the 25 over. So it's minus 24 is equal to 0. What can you factor out? Very good. What did I just solve for? My y values and my intersection points, negative 4 and positive 3. I have an equation right here, x equals 1 plus y, that could tell me my x values. Plug in negative 4. 1 plus negative 4 is negative 3. And 3 plus 1 is 4. As you look at those coordinates, do those appear to match my drawing? Yeah, they're right on. Okay, we're not going to do number 4, but real quick, if you choose this, what does the first graph look like? An ellipse. Second one is a line. Look at number 5. What shape is the top one? Hyperbola, the bottom one? A line. Number 6, what's the top one? An ellipse. Divide through by 13. That's what you'll have to do if you choose 6. And then the bottom one is a line. Number 7, the top one, will be a hyperbola. When you subtract the y squared over, the y will be negative. The bottom one is an ellipse. We do number 8 together right now. Okay, we'll do 8. What shape does the top one make? An ellipse. Looks better when it's in that form, doesn't it? What's the center of that ellipse? 2, 0. Let's stretch it. How far in the x direction? The square root of 6, which is about 2.5. How far in the y direction? Square root of 2. It's like 1.4. So that's a nice little general sketch of my ellipse. What's the bottom shape? Parabola. What's the vertex of that parabola? 2, 0 is the shift, right where this one is. Does it go up or down? Goes down. According to our drawing, how many intersection points does it appear to have? Appears to have 2. What do you notice about the y values of those intersection points? They're negative and they appear to be the same. So that's why, again, it's so good to get a drawing so you can see what might come up. Because this one we come up with kind of a weird solution. So we'll see what happens here. You could use elimination or substitution with this one. I would choose substitution. And here's why. You see the x minus 2 quantity squared? I have the same thing right over here. I can solve for an x minus 2 squared and use that. Some people want to take the y equals. They want to plug this thing in for y equals, but then you would have to square all that. I think that gets kind of messy. And then you come up with a quartic, fourth power. And I don't like that. So I'm going to do this. Last hour did not like this. First hour, no problem with it. So you guys tell me if you see a problem here. I want to solve for x minus 2 squared. So I need to multiply both sides by -3. So now I have x minus 2, that quantity squared. So instead of this x minus 2 squared up there, what can I put in its place? I can put the -3y. Yeah? Any problem with that? Nope. All right. Emily? Question? Taylor? Stay it. Okay, that's all right. We'll do it again. Watch. I won't even write it. I'll just advance forward. All right, so I have an x minus 2 squared, right? And so what I want to do is I multiply both sides by negative 3, and I get a negative 3y. So you can now see I have an x minus 2 squared, and I have an x minus 2 squared. So what I'm going to do is I'm going to take that x minus 2 squared, and I'm going to plug in for it negative 3y. That way my x's go away up here, and I just have my y's. Caitlin? X minus 2 quantity squared is the same as that, right? And it's equal to negative 3y. So instead of writing x minus 2 squared, I could just write a negative 3y. That way I don't have any x's up here, I will just have y's. So whenever you use substitution, you're used to solving for a variable. You don't have to. You could solve for 4. 4 worked out. I mean, anyway. All right. Let's write it out. Instead of x minus 2 quantity squared, I write negative 3y. Then I have my plus 3y squared, and that's equal to 6. I have a second degree equation now. How do you solve for second degrees? Set them equal to 0. So I have 3y squared minus 3y minus 6 equals 0. Now what? Factor out of 3. Y squared minus y minus 2. Does y squared minus y minus 2 factor? To what? Y plus 1, y minus 2. So I have solutions of look at my graph. Does it look like I could have y values of negative 1? How about this? Does it look like I could have a y value of positive 2? Y value of positive 2 would be above the x-axis. Doesn't look like that's possible, does it? I still need to find the x value, don't I? Let's see what happens. Let's use this equation and find the x values. For my y value, I'll plug in 2, and I will get negative 6 equals x minus 2 quantity squared. If you're going to solve for that x value, what do you have to do to both sides? Square root. And when you square root both sides, you'll take the square root of a, which is imaginary. So you can tell that this does not give you a solution. The algebra told you when you plugged it back in, you saw you get imaginary. So let's try negative 1. Negative 1 times negative 3 is 3 equals x minus 2 quantity squared. But I want to solve, what do I do to both sides? Square root of 3 plus or minus is equal to x minus 2. What's my last step? Add the 2. 2 plus or minus the root of 3 is equal to x. So you can see those are your two solutions. 2 plus the root of 3 with negative 1, and 2 minus the root of 3 with negative 1. That's our solution. What you think? One more problem together. This one's quick. Backside. Number 10. What shape does the top one make? Bottom one? What's the center of the hyperbola? 0, 0. I'm going to make my box. How many units in the x direction? 4. How many units in the y direction? Root of, which is like 2.5 or something. Make my box. Draw my symptotes. And is this a horizontal hyperbola or a vertical one? Why? Because y is negative and x is first. Very good. That's my hyperbola. What's the center of my ellipse? How many units is it stretched horizontally? 4. How many units is it stretched vertically? 4. How many places does it look like it intersects? Can you tell what those 2 places are? Let's confirm them algebraically. Sure looks like it's positive 4, 0 and negative 4, 0, doesn't it? Now, substitution or elimination? Elimination. It'd be tough to solve for x or solve for y. You can do it, but a lot more work. If I multiply the top through by a negative 1, and I add them together, what's going to happen? The x squared over 16s will disappear. Negative x squared over 16 plus positive x squared over 16, nothing. Then you get y squared over 7 plus y squared over 49 equals, what's negative 1 plus 1? 0. So that's what I have to solve. In order to add 2 fractions together, I have to have common denominators. Multiply top and bottom by 7. It's 7y squared over 49 plus 1y squared over 49 equals 0. Add those together, what do you get? 8y squared over 49 equals 0. How do you get rid of 8 over 49? Multiply by 49 over 8. What's 49 over 8 times 0? 0. What's square root of 0? 0. Are you surprised that your y value came out to be 0? Y value 0. Plug it back in to solve for x. X squared over 16. What's 0 squared over 49? Equals 1. Multiply both sides by 16. If x squared is 16, what's x? 4, and those are 2 solutions. There's your conic sections. Graphing them, solving algebraically. There's 7 left on your sheet. Pick 4. XY equals 15 is a hyperbola, though we haven't learned how to graph them. So yeah, 12, you technically don't know what that graph looks like on the bottom, so you might not want to choose that one.